The derivation of the formulas used in the calculator tricks. For the ln of x, y is equal to a to the x. Therefore, y prime at 0 is equal to ax0 ln of a. From Newton approximation, y1 is equal to y0 plus the y prime at 0 times the delta x, x1 minus x0. y1 is equal to y0 plus the derivative is a to the x0 ln of a times x1 minus x0, which is this one. So ax1 is equal to ax0 plus ax0 ln of a times x1 minus x0. So rearranging x1 is equal to ax0 multiplied by 1 plus ln of a times x1 minus x0. And rearranging ax1 over ax0 is equal to 1 plus ln a times x1 minus x0. Therefore, ln of a is equal to ax1 over ax0 minus 1 divided by x1 minus x0. So this approximation is very accurate if the delta x, x1 minus x0, approaches a zero value, very small value. So if we assume that ax0 is equal to 0, therefore this is 0 and x1 must approach 0. So ax0 is equal to 1 if we assume x0 is equal to 0. So substituting back here, ln of a equal to ax1 over 1, which is ax0, minus 1 over x1 minus 0. So when x is very small, ln of a is approximately equal to a to the x minus 1 over x. X is very small. If let's say x is equal to 0.001, then ln of a equals to a raised to the 0.0001 minus 1 divided by 0.0001, or it's equal to 10,000 times a raised to the 0.0001 minus 1. But simple calculator can't compute a raised to the 0.0001. In the simple calculator, there's a square root function. When you enter a and press once of the square root function, that means you're getting a raised to the 1/2. You press the second time, you'll get a raised to the 1/4. You press the third time, you get a raised to the 1/8, and so on and so forth, until let's say you reach the 11 time you press the square root sign, then that is equivalent to a raised to the 1 over 2048, or a is equal to a raised to the 0.000488. If you press 12 times, that means it's equal to a raised to the 1 over 4096, or a raised to the 0.000244. So by pressing the square root sign n times, that is equal to a raised to the 1 over 2 raised to the n. So if n is equal to 11, that means it's equal to a raised to the 1 over 2 to the 11, or a raised to the 1 over 2048. Let's use n is equal to 11 times. ln of a therefore equals to ax minus 1 over x. If x is equal to 1 over 2 to the n, or 2 to 1 over 2 to the 11, or equal to 1 over 2048, then ln of a equals to a raised to the 1 over 2048 minus 1 divided by 1 over 2048. Therefore, ln of a equals to 2048 times a raised to the 1 over 2048 minus 1. If you use n is equal to 12 times, that means x raised to the 1 over 2 to the 12, or x raised to the 1 over 4096. Then you can also calculate ln of a is equal to 4096 times a raised to the 1 over 4096 minus 1. So you can use both of this formula, but for simplicity, just use this one. So you don't need to press 12 times, just press 11 times. So regarding the log of x to the base 10, you can calculate that to equals to ln of x divided by ln of 10. And if we use the previous formula, that's 2048 times x to the 1 over 2048 minus 1 divided by 2048 times 10 raised to the 1 over 2048 minus 1. So therefore, log of x to the base 10 is equal to x raised to the 1 over 2048 minus 1 over 10 raised to the 1 over 2048 minus 1. Or if you use shortcut, then you evaluate this one, you'll find this is equal to equivalent to 888.9352 times x raised to the 1 over 2048 minus 1. Derivation for y is equal to a to the x. So y is equal to a to the x. Therefore, ln of y equals to ln of a to the x, which is equal to x ln of a. So from previous derivation, ln of n equals to 2048 times n raised to the 1 over 2048 minus 1. So we use this formula to find for the ln of y. So therefore, ln of y is equal to 2048 times y raised to the 1 over 2048 minus 1 is equal to x, which and ln of a is 2048 times a raised to the 1 over 2048 minus 1. So simplifying and cancelling out this 2048, you get y to the 1 over 2048 minus 1 is equal to x times 1a raised to 1 over 2048 minus 1. So therefore, you can get y is equal to this, or the final formula will be a to the x equals to x multiplied by parenthesis a raised to the 1 over 2048 minus 1, then plus 1, all raised to a power of 2048. For a simple calculator, after entering a number, the one press of x and equal sign will raise the number to n square. The second press of x and equal sign will raise it to n to the fourth. The third press of x and equal sign equals to n raised to the 8, and so forth. So by pressing 11 times the multiply key and the equal key, it's equivalent to raising that number to 2048. If you press 12 times the times and equal, then you're raising that number to 4096. So for derivation for the e to the x function, a to the x is equal to x times a raised to the 1 over 2048 minus 1 plus 1 raised to the 2048. But if a is equal to e, which you want to solve for e to the x, then that means e to the x therefore is equal to x multiplied by replacing a by e, then e is raised to the 1 over 2048 minus 1 plus 1 times 24 raised to the 2048. So simplifying, evaluating this e raised to the 1 over 2048 minus 1 you will get e to the x is equal to x over 2047.5 plus 1 all raised to 2048. Because if we use a scientific calculator, we can find that e raised to the 1 over 2048 minus 1 is equal to 1 over 2047.5.